Shall we start? Shall we start? Shall we start the problem? Okay. 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 So just intimate me once you are done. We'll start this particular problem. Okay. Okay. So first let us note down the given data and then we will proceed with the problem. Okay. So the given data for this particular problem, let us try to analyze. Okay. Number one. So what are the following data is given for the V-belt connecting 20 kilowatt motor pulley to a compressor. So there is a motor pulley, which is driver. So this particular thing is a driver, and there is a driven pulley, which is a compressor. And this one is the driven pulley. Okay. Now, okay. So driver data, all the things are given. So pitch dia is being given. So small d is being specified here. This is 300 mm for this, and speed is given. That is the speed of the smaller pulley. I can say it is 1440 RPM. Next, coefficient of friction mu value is 0.2 for that. First of all, power transmission is given. I will just note down that so that I will not forget it. Next, compressor, which is driven pulley, and that is capital D. I would take it as 900 mm. Speed of which is 480 RPM. Next, mu is same again, so 0.2. Next, what else? The center distance between the pulleys is 1 meter, so C is specified as 1 meter there. Okay. The cross section of the belt is trapezoidal, that we all know that. So cross section of the belt would be a trapezoidal in nature. Okay. With parallel sides being 12 mm and 22 mm respectively. Parallel sides in the sense these two sides, the data is being given, which is 22 mm on the longer side and 12 mm on the shorter. So this data is being specified. The depth is 14 mm. That means the overall height of this trapezoidal section is how much? It is 14 mm. Okay. The density of the composite belt is 0.97. Look at the units. So rho is specified, but look at the units. It is 0.97 grams per cc, in the sense it is centimeter cube. Cc is nothing but centimeter cube. Next, the allowable tension per belt he has given. He has not given the design stress. Be aware of it. he has given the tension. So design tension he has given, that is 850 newtons. Determine the number of welds required for this particular operation. So number of welds. So what we need to find here, to find is the number of welds. That is nothing but the value of n dash you have to find. Clear about this particular problem? Any doubts? Shall we proceed? Shall we proceed with the solution?
Yes, sir.
Good. So I told you in the last class, I even intimated you in the last class that there would be some kind of problems where the value of A would not be specified directly. Okay, rather he will give you the section details from which you are supposed to calculate the area. I have told you in the last class. So how many of you know how to calculate the area of a trapezoid? I need answers from you. How many of you know how to calculate the area of a trapezoid that is required for this? So now what I require is, I must calculate the area. So solutions will be writing in blue color. So area is nothing but it is an area of a trapezoid. Okay. So what is the formula? Okay, Nitish has said something. It is, what is A, what is B, and what is H, Nitish? Can you just explain it?
A is 22 mm, B is 12, and height 14.
Okay, good. So I can say A and B are nothing but the parallel sides. So A is 22 mm, B is 12 mm, and height is nothing but, just a minute. So full brightness, it's getting heated. Right. So that is known. So I will take that formula which Nitish has given me. So area is equals to, I will just put it in right order. It is H1, not H, divided by 2 into A plus B. Is that right, Nitish?
Yes, sir.
Now please do calculate according to this formula. So it is 14 mm by 2 cross 12 plus 22 or 22 plus 12, whatever it is. So from this, what is the value of A in m square?
$224.
Yes, what is the value of A? 238 mm square. Okay, so 238 mm square. Now, observe this. The design stress is not given, rather than the tension is being given. So from which you are supposed to calculate the design stress. So if the force is given and you are asked to calculate the stress, how will you do it? Anyone? How will you do it? 238 mm square. Okay. So if the force is given for some body and you are asked to calculate the stress, so how will you do it? Basic question. How will you do it? Force by area. So the force divided by area. Force here is the tension force divided by area. So force is 850 newtons divided by area is 238. Sorry, 238 mm square. So now, what is the design stress? From this, I would get the value in Newton per mm square. Yes, 3.57 Newton per mm square. So now I got the value. Now, whatever the data he has given, I'm just altering those things uh, for my convenience. Is there any data? Should I alter it more? Any data is left so that I have to alter it. For example, area I have calculated like that. Density, yes, exactly. So density is being specified as 0.97 grams per centimeter cube. In what units I'm expecting the density to be? Kg per meter cube. So how do I convert 0.97 into kg per meter cube? Yes, exactly. So kg per meter cube, how do I can convert this particular factor? Yes. So it is 0.97 into gram, in the sense it is 10 to the power of minus 3 kg. Kg is done. Centimeter cube, I have to convert it in meter cube. So 1 centimeter is equals to 10 to the power of minus 2 meters. Whole cube is there, so I would specify it as whole cube. Now what I have got is kg per meter cube as density. So what is this value? In kg per meter cube. Give me in a proper format. 0.97 into 10 to the power of minus 3 divided by 10 to the power of 0.97 into 10 to the power of 3. 970, can I take it as 970 kg per meter cube? Okay. Now, anything else is left to convert or bring it in a proper format? Anything else is left? Can we proceed with the solution? Can we proceed with the solution? Yes, good. So going with the solution, you have that particular thing, same formula, 14.16a. Use that. So since mu is same, always go with the smaller pulley because the mu is same. If you observe, it is 0.2 here and 0.2 here. It is mu is same. Therefore, go with the smaller pulley always. So for that, you require angle of contact. So capital D is specified, small d is specified, correct? And even the capital C, there is the center distance is specified. Substitute all these and get the value of the theta s. How much is the value? Okay, 2.54 radians, 2.54 radians. Okay. Now, next, immediately you have to calculate mu1. Remember, for the V belt, it would be mu1, not just mu there. So, apparent value of friction. Yes, there is one new concept to be learned here, I can say. This is sine. Sine. Is the value of alpha is specified? alpha is specified in the problem. So take this as a note. If alpha is not specified, so how much you are supposed to assume it? How much you are supposed to assume it? It is 40 degrees. So please note, if alpha is not specified in the problem, you are supposed to assume as 40s. Most of the builds, what I have seen in the past industry also, all will be having 40 degrees. It is a common thing what we follow. Okay, I have seen very rare builds, not even a single build, in fact, which has 50 or 60 degrees inclination of V build. All are 40 degrees standard. In India, I'm talking about. In other nations, they might use other angles. Okay, so whatever you get in the market, all will be of 40. 40 degrees, so substitute as 40 degrees there. 0.584 is the value of operant friction. 0.584 is now you calculate theta s. If you want to calculate theta s, you can do it. Theta into mu you can calculate, or else you can directly substitute in the e to the power of mu into theta. So I have already calculated the area of build. It was 238 something mm square. Next velocity. Next step is velocity. You require velocity for the calculation. Just that, substitute the things and calculate the velocity. Note it has to be on the smaller pulley. Don't take the larger pulley. Nothing much changes. A little bit changes. That's it. So always preferably you take the smaller pulley in order to calculate the velocity. So design stress I have already calculated it. So it is around sigma d. Okay. How much it was? It was design stress was 3.57 Newton per annum square. So 22.61 is the velocity. Now the last step, since you have known all the values, substitute all the values in the equations and give me the number of bend. If I am moving very fast, so if you're not able to cope up with what I am doing it, please stop me, okay? I want everyone to solve along with me. That is my intention. So if I'm moving fast and you are lagging behind, please stop me at any moment. We will wait for you, okay? Okay. Sorry, man. I did not see your messages. Okay, 1.56, 1.59. Okay, so we take 1.56. So approximately it is 2 minutes. Okay, we shall move with the next problem. The fourth one. So once you have done copying this particular question, please let me know. We shall start the solution of it. Okay, shall we start? Yes, okay. So this particular problem is very interesting from whatever the problems we have. Those are typical problems, like very rare, but they are interesting to be solved. Okay, let us try to understand the problem what he has given. Okay, so given a V-belt drive is required to transmit 19 kilowatt at 1500 rpm from a 250 mm pitch diameter sheave to a 900 mm diameter flat pulley. So that is the data given. So what is happening here is the belt used is V belt. Okay, the belt used is V belt, but the pulleys. So one is 250 mm pitch diameter sheave to a 900 mm flat pulley. So sheave, difference between a sheave and a pulley is sheave will be having a groove inside it like this, which is used for a typical V-belt application. Okay, so this is a sheave. Flat belt pulley is nothing but a pulley which you are using for a flat belt. Okay, onto which the flat belt sits like this. Okay, that kind of flat belt pulley is made to run a V belt. Okay, so one is sheave, no doubt. The other one is a flat belt pulley like this. Hope you got the imagination. Yes. And the belt, just a minute, I'll just try to draw a diagram neatly so that you guys can understand it. Okay. So this is how it is. Now, this particular sort of arrangement, a belt is attached, which is a V in nature, which runs something like this. Understood? Hope you got the imagination. I have tried max to draw it properly. And the cross section of this, is a V build. Hope you got it. Hope you got the imagination. One is a V belt pulley. I would just write this is a V belt pulley. Okay, which is specifically made for the V belt, which has a groove in it. The other is the flat belt pulley, which does not have a groove. So this sort of weird arrangement is being made in this particular problem. Okay. So let us take the data, whatever he has given, and try to solve it. No much complications. It is easier. Okay. The thing is, you have to understand how arrangement is made. V-belt drive is required to transmit 19 kilowatts of power. So power required to transmit is 19 kilowatt. Okay. And speed of the smaller pulley, which is V-belt pulley, is 1500 RPM. Okay, 1500 RPM from 250 mm pitch diameter. Remember, whenever you specify a V-belt pulley, you will use a word pitch diameter. You will not use a word pitch diameter for this flat belt pulley. So this particular pitch diameter, small d, is equals to 250 mm, so 2500, 250 mm. That means I would just write sheave dia to be more clear, sheave dia. And the other one, the other side where it is a capital D, which is 900 mm, but here it is a flat pulley, flat pulley dia. Okay. Now, next, the center distance between the shafts is 1000 mm. So we just write the center distance between the shafts is how much? It is 1000 mm. Okay, that is the center distance. Next, the groove angle is 40 degrees. Now here, the groove angle alpha is 40 degrees common. The coefficient of friction between the belt and the sheave is 0.2. That means it is mu s here, isn't it? Am I right? Belt and the sheave he is saying. Then it is small s, mu s. Am I right? Yes or no? So mu s is 0.2. Okay, same value is specifying. Why is making us to confuse me? Okay, 0.2. And that of belt and the flat pulley, that means mu L, is being specified as how much? Again, it is 0.2. Okay. The cross section of the belt is 40 mm. Again, he has given us the cross section. I would just write that cross section something like this. Okay. Or I would take it as on the either side. Okay. So how do I specify it? Better I will make something like this. I'll not make it more complicated. Let it be like that itself. Okay. The cross section is something like this. Trapezoid. Okay. This cross section values he has given. How much is those values? One side. The cross section of belt is 40 mm on the wide at the top and 20 mm wide at the bottom. Okay. So it is on either side. Okay. It says the cross section of the belt is 40 mm wide at the top. So this is 40 mm. 40 mm. Okay. Next it is 20 mm at the bottom. 20 mm. Okay. And 25 mm deep. 25 mm deep. Okay, that's great. Each belt weighs kilonewton per meter. So the weight is being specified again in another fashion. So weight is specified how much? It is 9810 kilonewton per meter. It is okay, kilonewton per meter that you have to convert. Okay, kilonewton per meter cube or meter. Sometimes it is wrong. It is meter cube. change in the question. It is meter cube. Wrongly given that it is kilonewton per meter cube. Okay, done. Next, the allowable tension in the belt is 1000 mm. So allowable tension in the sense it is design tension, that is 1000 Newton. Okay, so this is all the things we have. Determine the number of belts again to find the same old thing, which is the number of belts. Okay, so just by looking at the data, whatever you have, can you just specify what are the first few steps that I have to do? Later on, we will look into the complications of this flat belt buoy involved in this particular problem. Nothing changes, only the value of theta s, where you calculate, there you should be very careful about it. That's it. Okay, nothing changes in this particular problem. Yes. Yes. First we will calculate the area. Okay, man, as you wish. So area of a trapezoid. Area of trapezoid. Same thing. A is equals to h divided by 2 into a plus b. H is 25 divided by 2 into 40 plus 20. So from this, what is the value of in mm square? The value of A. So 750 mm square. Good man. 750. So it is 750 mm square. Okay. Now, next, what is the next step so that you can do it without my help? Very good. So design stress is, design tension is given. So from that you can calculate the design stress. So divided by area, it is 1000 divided by 750. So how much it is? It would be Newton per mm square. So from this, sigma d would be equal to Newton per mm square. 1.33 Newton per mm square. Now, what else? Density, I think it is in the fusible units itself. Do I need to change it? So weight, that is nothing but he has given the value of omega directly. Correct, alva? Kg per meter cube, kilonewton per meter cube, he has given us the value of omega directly. Correct. Okay. So just observe the formula, 14 point, whatever you have that particular formula, n dash AV divided by 1000 into sigma d, all the stuff. And can you just say me, what is the hindrance in this particular problem? What is stopping you? If I just take that particular expression, which is this, okay, I would just tick mark. Do I know the value of power? Power is done. Area is being calculated. Velocity. So velocity you can calculate here. We have already calculated the area. Area is 750 mm square. I'll just update here also. So it is 750. Now, what is the velocity of the belt? Please do calculate it. Okay, 19.63 is the velocity. So 19.63. Now, even the velocity is being calculated, so I'll just tick mark those things. Sigma d, I know the value of sigma d, so I'll just tick mark at omega. I know it is g, anyhow I know. So what is stopping you now? What is stopping you? Mu and theta, mu is nothing but it is mu1 it is, so it is mu divided by sine of alpha divided by 2. Theta, in the sense theta you can calculate pi minus capital D, something formula is there, no, you can use that particular thing to calculate the value of theta. So what's special in this problem? why it is why it is made so much complex? I mean to say, we build flat bed and the you can do it, no? Mu1 you have, theta you have, you can calculate the value of mu1, you can calculate the value of theta, substitute it, calculate the number of beds. So if I do so, whether my problem would be correct, anyhow I'll be getting the value of n dash. So what's big deal in this problem? Groove. Okay, groove is there. I am calculating, no, I am calculating mu, I am calculating theta, I am substituting here, getting the value of n dash. Yes, I want you to respond, I want you to talk on this. Because unless and until flat belt, V belt pulley, yes, definitely it is given. I need an exact answer. So I have the solution in front of my eyes. I have the value of mu1. I have the value of theta. In a second, I can calculate the value of mu1 and theta. I can substitute it here. I can calculate the value of n dash. Then what's great deal in this problem? What does a design procedure say? Area of contact of the pulley with the belt. It's better you talk, man. Angle will change. Which angle, Rafiq? BCA, BCAs of the sheave. Right? So it's better you talk. Because of sheave, angle will change. Okay. See, whatever the pulleys which you have used till now, all are sheaves only. Sheave antane ಹೇಳೋದು ಅದಕ್ಕೆ, but ನಾವು pulley ಅಂತ ಕರೀತೇವೆ ಅಷ್ಟೇ. ಅದು sheave. That is why you are calculating the value of mu1. Outer dia not given, na? Not given. It is given, no? Nodi.
So for flat belts we use mu, and here we use mu1.
Okay, yes, you are right. For flat belts, we use the value of mu, but for the V-belt pulley, you use the value of mu1. So, we're almost close. So, what big difference does it make?
Power will be different.
Will be different. Okay. What does a design procedure say? Anyone. So, which value should I take for mu theta? Okay. According to the design procedure, which value should I take for mu theta? Whether it is for the smaller pulley or for the larger pulley. So, which one should I take? Mu theta value. Who told you smaller? Why you are taking smaller, Dhanush? Yake? Okay, I know. Why you are taking smaller pulley? What made you to take smaller pulley? On when will you take a smaller pulley? So please do observe, take the previous problem for instance. See this line, what you have written, I have been stressing on this every time. What it is written there? Can anyone just read it? Hrithik Sanil, Nandan.
Since U is same for both the pulleys, design is based on smaller pulley.
So since mu is same for both the pulleys, then you are considering the smaller pulley. So inevitably, mu s, theta s, mu n, theta l. So these two values you have to compare. So whichever is the smaller value, that you have to take for your calculation. If mu is same for both the pulleys, definitely the theta s would be a smaller value when compared to theta l. Yes or no? Theta s will be automatically smaller. So that is why you need not calculate the value of theta l. You can directly take the theta s itself. Because since mu is same for both the pulleys, if mu is not same, what is the actual procedure that you have to follow? Nitish? Now mu is not same in my case. Definitely I know. So here it is mu 1, here it is mu. Now definitely mu is not same. So what is the actual procedure that I have to follow? Nitish?
You have to calculate the value of mu.
Yes, first we have to calculate the value of mu1 into theta s, correct? And next you have to calculate the value of mu into theta l. Then you have to compare these two values. Whichever is the smaller value, that you have to take it for the calculation. Am I clear about this? Did you understand? Everyone. I want replies from everyone. Okay, this is very important point. Yes, so you have to calculate mu1 into theta s for this V belt. For the flat belt, you have to calculate mu into theta L. Then compare these two values. Whichever is a smaller value, that you have to pick for your calculation of number of belts, which is here. So once the mu theta value is being calculated, I guess you can easily calculate the value of n dash, and there ends the problem. Okay. So this is a problem for you. So we shall please try this problem. This is a little bit complex. Do not try it. I will explain you how do I calculate the value of mu1 into theta s. How do I calculate the value of mu into theta l in the next class, and we shall compare those two. After that, we can inevitably solve for number of bits. We'll do it in the next class. Enjoy your Sunday. Mark your attendance in the Google Sheet. We shall end the class here. Okay? Take care.
Sir,
Radvik, ಹೇಳು.
attendance.
Attendance ಅಲ್ಲ? Radvik.
Sir, Harsha.
Okay. Radvik, okay, done. Harsha. Okay, dear. Thanks a lot.